What's up, y'all? We're going to work on the LeetCode 2-sum problem today. I'm going to show y'all the solution that I did, and I'm going to talk y'all through how we do it, how we go about it, and why it works. I'm going to try to make this video into as deep of a dive as possible, so you can use the stuff you learn here to solve other coding problems. I wanted to do this live, but these problems are so hard and so finicky. You'd probably see myself, getting a lot of things wrong and getting frustrated. So better for me to just come up with a solution first and then talk you all through it. So I'm gonna go to I'm gonna go here to the problem because understanding the problem is so important, especially when you're doing these things. It's almost more important than knowing how to code. Because you'll be hit with one of these problems and you'll just be like, wait, what? Huh? So it's important to, take a few minutes to understand the problem and to unpack it before trying to find a solution. So this problem's called 2-sum. And basically, we're going to say, given an array of integers called nums and an integer called target, return the indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution. You may not use the same element twice. You can return the answer in a new order. When I first read that, I was like, wait, what the heck, huh? So it kind of helped me to conceptualize that out. So if we look down here, this makes it a lot easier to actually understand what it's even saying. So we have an array of nums, we have a target, and then we have the indices. So the indices of 0 and 1, which is 2 and 7, will add up to 9. The indices of 1 and 2, which is 2 and 4, will add up to 6. And the indices of 0 and 1, i.e. 3 and 3, will add up to 6. And in our constraints here, the array can be really big. I believe 10 to the power of 4, that's something nuts. It's like 10,000. And you can just see the constraints are huge. So there's so many different things they can hit you with, and they will hit you with every niggly little edge case you could think of. So now that we understand what the problem is, we're going to go toward the solution. So let's go here. Let me pull up my Visual Studio Code because it's very helpful if I can just code it out myself and just bring it down here so I can play with it more so I'm not stuck in the LeetCode editor. So I'm going to go through here. So first we want to catch edge cases. That's generally the first thing I try to do when I'm solving one of these kind of problems because it's easy. It's an easy thing to start with, so you can start there. And 2, edge cases are going to come up in these kind of problems, so you got to figure them out. So the first thing I found out in terms of edge cases is any list that has a size of 2 will always return the first 2 indices. So if we're, going back to, if we're going back over here, like this one here, it's always going to equal 0, 1. Even if it's 10 and 10 and the target's 20, or it's 0 and 0 and the target is 0, or it's 1 and 1 and the target is 2, we're always going to get this output. So whenever we have that happen, you're always going to get that output. So here I'm just basically putting an if statement in the beginning, and it's saying if the length of nums is equal to 2, then we're going to print 0 and 1. And we're going to say if double equals, not single equals, it's an exact equivalent. So we have that out of the way. I'm going to skip this part up here for now, and I'm going to go down here. So the real meat of this code is, just a basic math problem. We have to subtract the target by these different nums to find a match. So if we're using this one up here, the target is 10 over here, so we're going to have to say, all right, 10 minus 2 is 8, so we're going to say, all right, if that's a match, we're going to look for another 8 in here. 10 minus 5 is 5, so we're going to say, all right, look for another 5. 10 minus 11 would be minus 1, so we'd be looking for a negative 1. I'll use a different example here that does not have multiples, so we're going to go down here. And then we'll say, let's just say 11, why not? So yeah, same here, it'll say 0 minus 11, any 11s here? No. 11 minus 3, any 8s here? No. 11 minus 2, any 9s here? Yes, there is a 9. So that's basically the logic of how it's going to work. And I'm going to put it all together, but we see this if statement down here is basically doing that. We're looping through the nums array, and then we're putting an if statement here, and just going to say if solution is in nums, and then I'll discuss this part of it later. But we just are going to append this iter value here, and iter is equal to 0, and then iter plus equals 1. So iter will be equal to the index of whatever we want. It's just a simple way to get an index. So whatever index we're at is going to be good, so we're going to do that. But if we have duplicates, like in this one over here or this one here, this in statement in Python, it just returns a simple true or false really on the back end, and it's always going to return the first instance. And it's like the second instance does not even exist. So like over here, it's just going to return the first instance of 5, and the second 5, it's going to be like, it's that second 5, we don't care about that. So because of the limitations of Python's in function, we're going to have to catch duplicates. And the thing about catching duplicates, though, is if the answer is a duplicate, that duplicate is always going to equal target. Otherwise, that duplicate wouldn't be there. And what I mean by that is, if we go here, and we go here, and we go here, if we do 10 minus 5, and it says, yeah, 10 minus 5 is 5, and then it's always going to be, so if your target subtracted by something equals that duplicate, it's always going to be a duplicate value. Otherwise, that duplicate wouldn't be there, because this is a very rigid problem. It has to have there's always going to be two numbers that equal target no matter what. So in the case of duplicate values, and I'm trying to think of how to explain that better, but essentially we can just manually catch the duplicates. We don't have to really do too much math on them or anything like that. If we have that duplicate, we can just assume, okay, we're good here. Because, like, for example here, like, if we do, 10 minus 5 equals 5, it's like 10 minus 5 equals itself, or equal to, it has to, It's the only, it's just constrained. It's the only way it's going to go. So here, we're just saying if solution is equal to target minus I, so in other words, if target minus I, is going to be equal to, we're just calling that solution, but if what we're doing here, where we're doing our subtraction, if that's always equaling, well, not equaling target exactly, but if that's lining up like that, then we're just going to grab that value. So we're going to use this if statement. So we're going to say if it's duplicate, and if our iterator is not equal to the duplicate iterator is not equal to dupe iterator, we're going to append duplicate iterator, and we're going to append iterator. But the first, this is a little complicated the way I'm explaining it, but we catch that first here. So we go down here first, actually, and then we say if I is equal to solution, we're going to say, all right, duplicate's going to equal I, and then duplicate iterator, or duplicate indice is going to equal iterator, and then we can, so we can just save that value, essentially. So that's all we're doing here is we're just, whatever indice you were at, we're just going to save that for later because we're going to need it. And then duplicate set here to none, so duplicate is going to be set to I, just so we can say, all right, let's find this next duplicate that we have. So then it goes up here and it catches it, and it goes, ah, you have a duplicate. Okay, cool. And that duplicate is not just the first value we looked at. It's a different indice. It's the duplicate, and it's at a different indice. It's not the matching indice. And then we just append it all. So I'm going to run it right quick. And yeah, we get 2 and 1. Brilliant. And I'm also going to run the debugger too. Especially on these kind of problems, it's very helpful to just get an inside look at what's going on. So we're going to run the debugger. All right. So we're going to skip that. Nope. No on all counts. We're just going to go through again. Now it's going to catch this, and you can see here, it's going to set it. So now duplicate set to 5, and now we have the duplicate indices set to 1, so we have those values saved. It's going to do the same thing here, but now this is going to catch it, and it's going to say if I is equal to duplicate, which it is, and iter is at a different indice, so it is. It's pointing somewhere else. We're going to append it. We're going to say, okay, cool. We're going to append that and append that. And, you know, in a real function, I would return out too, but we're going to loop through everything. Probably be more efficient to just return out right there, but we're not going to do that. We're not going to worry about max peak efficiency here, but you can see the basic gist of what that does, and get rid of that debug terminal. And then I'm going to change it to a different one so you guys can see. So this one I'm going to say 11, and boom, we're working. Sweet. 2 and 4, those are the correct indices. Boom, this is 2, this is 4, perfect. Alright, so now we're going to go over to LeetCode. I've got that plugged in there. We're going to pop over to LeetCode. We're going to take a look at my code here, which is the same. We're returning it instead of printing it, but it's the same kind of idea. We're going to hit submit. And we are successful. Our runtime is not crazy fast, but it's good enough. And yeah, that is it. I'm going to add in a little bit of extra credits. I'm going to add a break statement here. See if that will save us some time. See if we can get a little bit of a faster. Our memory is still pretty good. Let's see if we can get a little bit of a faster runtime here. Okay, the break statement didn't do much, but I could probably add some little more efficient things in. But yeah, this is it. This is the two-sum solution right here. Took me a little while to come up with this, but I think it's pretty intuitive. It's relatively easy to understand. And yeah, I think that's going to do it for this video. Thank you all for watching. Happy coding. I hope this helped out. And yeah, peace out, y'all.